Okay.
If you add the two shortest sides, it has to be greater than the longest side.
Okay, thank you. Yep. The sum of, that's not what I want. As Caden said, the sum of the two shortest sides is is wow. Yep, is greater than the third, and the third would be the largest side, right? So that's what we call as our triangle inequality theorem. Not just any three random sides can make a triangle, as we saw looking with our spaghetti on Friday and filling out our table. So there does have to be something happening there. All right, might need a calculator, so let's take that and let's go through number 4 there. Okay, let's take number 4 right there. So as I'm hearing from a few of you, it's got to be greater than, but not equal to. Correct. So let's run through that really quick. What do we have on that first one? A yes or a no?
No.
No. Because what do we get for the sum here? 34 and 40, 70, what? 4? And that is what? Yeah, not greater than, is it? Our next one is what? No. 50 and what? 33 is what? 38? And that's another no, as you said. What about the next one?
Nope.
No, because that one is, you said no. So that is, well, that is a no, because we can't be equal to. And on that last one, what do we get for sum?
Yes.
18, 13 is 31. And we finally get ourselves a, as you said, a yes. Okay? So that's our big thing to remember from that today. Now, there's a follow-up from our triangle inequality theorem, which we've already started looking at. Back to our right triangle, okay? Back to our right triangle, of those three sides, the legs and the hypotenuse, what should always be the largest side? Hypotenuse. Why is it the largest side? What angle is it across from? It's across from the 90 degrees. So in there, okay, looking at that triangle DOG there, okay, there is a relationship between the side lengths and the angle measures. So when we look at that, all right, what is my smallest angle? What's my smallest side up there? 3 and 36.9, right? So in my 3, 4, 5, all right, our 3, 4, 5 is our go-to. You said 3, and that goes with 36.9, right? So the smallest angle, which is 36.9, is always going to be opposite the smallest side. So that size of that angle, whatever that size is, it's the smallest angle. Doesn't it make sense as it opens up? It's going to open up to make the smallest size of the side. Okay? So that relationship is going to be there. You remember that the largest angle, which in this case is angle what? O? Angle O is opposite, in this case, GD, which is 5, is opposite angle O. It's a hypotenuse. So then if I'm opening up to 90 degrees, it makes sense that it's going to make, I'm hoping it makes sense, it's going to make the what? Largest side. So there's this relationship that's always happening here, is that the size of the angle is opposite the size of its opposite side. That's what I want you to take away from this, okay? So if two angles of a triangle are not congruent, so let's not worry about that, okay? Then the longer side lies opposite the what? Largest angle, right? The largest angle. That's what we want to keep in mind. So we want to, I always go back to small, medium, large, or you're the Starbucks type of person, grande venti and what's the other one? Tall, thank you. I don't know why it's Starbucks, who knows. Let's go and keep that in mind. And let's list out these sides then from smallest to largest. So small, medium, large, or tall, venti, grande, whatever the order is. Okay? If I took away your side links here, and then relying just on our angle measures, let's go list out our sides, because I don't care about the angle measures. We could all list out 64, 50, and 66. And my son, that's the second grade, can do that. All right, let's list out the side links then from smallest to largest. So small, medium, and large. What is my smallest side up there? Hold on, side. AB, right? So I'm gonna go look at that smallest angle, which is 50. Yes, that's right here. It's angle C. I like to draw arrows to point to where I'm going across to. So angle C is opposite AB, right? So AB starts it off. That's my smallest side. Angle, what's my medium one? Small, medium, large. Angle what? Oh, okay, gotcha. Yep, B is 64. Boom, AC is my medium one, right? AC we just said. And then large, cross elimination says BC. 66, angle A is my largest. Opposite that is BC, as you said. Okay? Took away your picture. Let's go with the next one. So on the next one here, taking away your picture, my suggestion as we've gone throughout this first semester, and hopefully you realize it, then make a picture. Does it have to be to scale? No. But especially our first time through here, some of you I know are a lot better at visualizing that yourself in your head. Great. But I always like to draw just a quick sketch. So what type of triangle do we have here? Triangle ABC again. And we get the 3 angle measures. Doesn't have to be, again, to scale. But throw in those 3 angle measures. And we can quickly go through and do the same thing then. A is what? B is what? And C is what? So as I drew mine out, obviously C is 110 degrees. Is that to scale? Heck no. All right. But I'm just kind of doing it so I can really more or less match up. C is opposite what side? That's really kind of what I'm doing there. Okay. All right. Play the matching game here. Now this time, reading the directions carefully, we're going to go from longest to shortest side. So what's my largest angle? Yep, it's C. 110 is opposite what side? AB. So large, medium, and small this time. So AB. And then medium is, yep, CB. And if you haven't maybe noticed already, before we do the last one, angle B is the small side. And then the other 2 points, the other 2 vertices in that triangle are your opposite sides. So angle B is my last angle, right? So therefore angle B, the other 2 points, the other 2 vertices are going to make up your longest side. So do I need necessarily the picture? No. I know angle B is the smallest side. Therefore A and C are going to make my smallest side. So AC is going to be, whatchamacallit, my smallest side then. Okay? Nothing crazy. We're going to use this relationship a ton as we come back in the second semester when we get into trigonometry. Okay? We're not there yet though. Now, same idea happens on the reverse of that. It makes sense then too that, as we've talked about it, if the 2 sides of a triangle are not congruent, then the larger angle lies opposite the largest side. So we can reverse that and do the same thing. So if I give you the side lengths we can list out the angles based off the size of the side links. Okay. So let's go and finish that off. All right. List me the angles from smallest to largest. So knowing nothing but the sides. Okay. And again, on here, if I just for say to glance at that, and I look at A, B, and C, the angle sizes, those are kind of hard to just look at. But now knowing the side length information, okay. So what we're doing here? Small to large. What's the smallest side up there? Small side. Okay. Yep. So smallest side is 3, which is AB, right? So first time through, again, I kind of always like to highlight things and take you back to the other side. To the angle. It's opposite angle. So you said it's 3, which is AB. And the non-included vertex is its opposite angle. So 3 is AB. AB, I didn't include C, so therefore it's my opposite angle. So angle C starts it off. Medium is 4.3. BC. B and C did not include A. That is correct. And then process elimination says my largest one is B. It's part of AC. And AC is going back to angle B. It's opposite angle B. I don't want to say that's it, but that's essentially it. If I don't have the picture, again, pictures are nice. But it is possible to do this without the picture, using the non-included vertex. So let's try to do that without the picture here. All right, stretch it just a bit. Now this one it says wants us to do largest to smallest. Large, medium, and small. Okay, what's my largest side up there? RY, which is 20, right? Therefore, what's my non-included vertex? G. So that's opposite G then. So RY is opposite angle G. If you draw out the picture, I promise you it gets that same thing. Medium is what? RG, which is 14. So what's its opposite one? There you go. And then lastly, GY is my smallest. GY is opposite what? That's it. Now when we take our quiz on Tuesday, I give these questions. Every year I have about, in every class, I'd say a quarter of the students not pay attention, and they go through on this type of question right here. I give you the 3 side links, and this is the answer they give me. They list these out from largest to smallest by saying this answer here. Largest to smallest. What did they just list out? All they did was list out 20, 14, and 12, largest to smallest. Congratulations, you all can list out 20, 14, and 12 from largest to smallest. I don't want the sides listed out from largest to smallest. I want the angles. So we do want to go that next step and take our triangle inequality theorem, apply it just a little bit more, and know about the opposites. So not the side links on this question, as we just did the angles. Same thing up above here. I'm going to have somebody that does it, I'm sure. Please don't. But I always have a ton of people do it. They say, oh, on this one, it's just going to be angle C, angle B, and angle A. Okay, those are quick points to lose. There's no partial credit or anything like that. Last one, let's do it. Now in the last one, what's the issue with the last one here? What's that? We're missing sides. That's definitely true. But with that, we do know some information there because that's a right angle, isn't it? And what's always true about the right angle? The opposite side is the greatest one, right? The largest one. So angle H, we're going sides and angles. So You know, that is the largest side, isn't it? So for the sides, and then we'll do the angles. For the sides, we've got the largest side, which is SA, right? And for the angles, we already got the largest angle, don't we? Which is angle H, right? Whoops, H. I mean, it's a right angle. Is there going to be an angle larger than a right angle? No, I mean, what's an angle larger than a right angle? 92 degrees. What's 90 plus 92? Can I have more than 180 degrees on a triangle? No, 180 is my max, so I can't have that. So 90 is my max. Okay, now after that, we got to do a little digging into that. Now, we're going to talk about this more the next couple days. We briefly have already talked about this triangle, though. What type of triangle do we have here, though? It's a right triangle. Keep going. It's an isosceles right triangle. Now, what do we know about an isosceles right triangle? They're congruent sides. So what does that tell me? Are these going to be larger than the hypotenuse? No. So these are equal, aren't they? So this is the case where HS and AH, they're not, one's not greater than the other, is it? They're just on equal footing, aren't they? I guess I could have, instead of putting even a comma, I guess I could have just put a congruent symbol there, right? Because they are the same length, like you said. What does that imply then you think about the two angles? It's the same thing, right? And we're going to talk about that more again the next few days. Because as we've been just saying here over this last few minutes here, the relationship between the size of the angle and the size of its opposite side. If these two sides are the same, then what? Here's HA. What angle is opposite HA? Which angle is opposite HA? S is, right? So we're right here. And what side is opposite HS? What's true about A and S? If these two sides are congruent, therefore those two angles are going to have to be congruent as well. They're going to be the same as well. What are those two sides? Sorry, what are those two angle measures then?
45.
Go farther. They're the same, but they are 45 degrees. Right, they are 45 degrees. They're congruent, they are 45 degrees. So angle A and angle S are the same level. We can't say one's more than the other because they are congruent, and we can go one step further and say this is a 45, 45, 90. And in January, February, when we get into trigonometry, we're going to talk about 45, 45, 90. That's a special right triangle. Okay? All right. So let's finally finish this off. Go find me the last missing side. We get the hypotenuse. Go find me those two side lengths. What are those two side lengths for HA and HS? If we don't know something, what do? Let it be variable. Correct. And you already told me they're the same side length. So what do we have then for our solving out for the x then? What are we going to use? The only thing that we know how to do with triangles is Pythagorean theorem. So let's take a step back all the way to like August, September, where we had set this up as a squared plus b squared equals c squared. That's correct. Okay? So old is new again, especially as we get into the second semester. We go into trigonometry, right triangles, Pythagorean theorem, which I actually play with the trig. Special rights. Not so much that trig, but special rights. Now, as I set that up, nobody's called me out on it yet.
Parentheses.
I forgot my parentheses. Right. 7√2. Got to be there. Because we talk about reviews for finals. I almost guarantee I'm going to give that one to you one more time. Finish it off. 7 root 2 squared better be correct. 7 root 2 squared better be what, somebody?
98.
If you're not getting a 98 there, still haven't learned how to do that correctly. Better be getting a 98 right there. X squared plus x squared combines to give us a what?
2x squared.
That's what we talked about again. I remember having that conversation with you. Some of you said x to the 4th. Some of you said 2x to the 4th. But it is just 2x squared. 1x squared plus 1x squared is 2x squared. Finish off. We're going to square root this thing. This is a quadratic equation. The only way we know how to solve a quadratics right now is square roots. In January, we're going to do factoring. We'll have a second method. But square roots is right now. Divide by 2. X squared equals 49, I believe.
Mm-hmm.
Square root that 49, and x is?
7.
X is? X is?
7. Negative and positive side?
Thank you.
Oh, God.
As we come back in January, I said we're going to talk about our factoring.
I
Okay?
forget about that.
So we have, again, at least two methods to solve quadratics. Square root is our first method. Factoring is our second method. Complete the square is another one. Quadratic formula is another one. Typically in quadratics, how many solutions do we get? Two. A positive and a negative. Do we typically keep a negative in geometry?
No.
No. I know I'm being kind of a insert your vulgar word there. Okay? But I know. But you guys are going to algebra 2 soon enough. Alright? You're going to keep both solutions. Alright, we'll pause it there.